Morning all. Today's session is going to be on voice control of IoT, and in particular how you might set up things like the, we'll look at the Amazon Echo and setting that up, but there's lots of other voice control systems about, such as the Google Home ones and the like. The lab associated with today is to show you how you can write your own skills, as they're called, for the Amazon Echo, and show you how you don't actually need to have an Amazon Echo to try it out. You've got an emulator for it, rather like a phone emulator for Android software. Just before I start on that, you may have seen an email that went out this morning. You may not have sort of read it yet. We're having quite a serious problem in some of the labs with some pilfering and stealing of equipment out of the cupboards. Now that directly affects you all. At the start of the year there were 30 kits in that cupboard in the different boxes. Yesterday when I came to do a lab for these little servo board that controls the motor, there were 5 in the cupboard. So 20 odd gone missing somewhere. And I know they're easy to pilfer because they're sort of postage stamp size. So we can get round it at the moment by we've got a large number of extra kits in. People can walk across the corridor and sign them out. But if you, I don't know what people do about that. Because apart from asking people to please just return them, or if you know somebody's got one that's not sort of out on official law, get them to return it, because it's really affecting your fellow students, really, more of that. And it's not just the boards, there are other ones as well, the RFID things, not as much in short supply, but still not 30 in there. I could say, luckily, we haven't been having full classes, we've only been having like 15 and 16 people coming along to labs. And people have been able to double up on it across the corridor and borrow one. If we do have sort of full labs, like we may well have over the next 2 weeks as the assignments due at the end of next week, again, there could be a sort of issue there to it. Certainly it's putting at risk future ways of presenting this course. We may not be able to do this sort of practical nature of the course in the future as that sort of thing goes on. So if you are aware of one of your colleagues or whatever who's sort of in that sort of situation, I could probably doubt it, because most people like them or brag about that sort of thing. Just try and prompt a few people to get them returned for that. Anyway, as I say, today's session is the using Amazon Echo and related devices. A couple of things just to sort of show that I can sort of pass some of these around, but because they're powered, you won't get to see what it does. I can give you a quick demo of some of them just here at the front. Just about everybody will be aware of the Amazon Echo and Dot for it, and I'll be going over variations on it. You're probably aware of Google's equivalent, Google Home, and lots of manufacturers are bringing out these standalone devices to work as an intelligent interface to using your devices around the home for it. There's many other manufacturers doing the same thing, and manufacturers of equipment having it built into the equipment, building into your car, building into your TV. Google, back in about 2 months ago, released their Home Hub, which is what this one is. Basically the same thing, but with a screen on. Amazon have got a similar thing out there already. You link into your local network and do whatever you want with them. I'll pass it around for a demo, but just as a quick look at it. We have a random musical artist or something like that, and anybody sort of tickling to a random band or something like that, or am I going to have to show my own musical taste when that's over there? Okay, Google, play Raikuda.
Okay, have a listen to this Raikuda station on YouTube.
He's all a bit slow and losing. Okay, Google, stop. And similar sort of things that you echo for answering questions and the like. Linking into your photo collection to that sort of cycle that we like to use photo frames to. Linking into your own music selection if you want, or public selections to sort of work on. I'll pass that round just to sort of have a look at, and you know what it. You may well have already sort of have one. Plug that. Not much to look at when you do pass it round, because it's not working. To just sort of like you're in the shop, I guess. It's got the same sort of approach that the Amazon Echo has. They typically have some sort of wake word to wake them up. They're listening to all sounds as they're coming in, and a certain key sound wakes you up to answer the question. There is the worry that a lot of people have on privacy of these, and it's monitoring all sounds going in. Is it, what are they actually listening to? You're inviting the listening device into your home, perhaps. But as I say, they're the same things if you work with the Echo One. That's got its own keyword. Alexa, what's the time?
The time is 10:08 a.m.
I've currently had to do that with an American accent. I had to swap the language settings over this morning, so it's American one, because there's a skill later on that I want to demonstrate that's only available if you're tuned into the American voice interface with it. You won't work with other ones. Similar to how you can get it to just do the usual things like your music and control things. Quick demo of working around the house here for it.
Alexa, turn off living room lights.
Okay.
Shut this one up, actually.
Alexa, turn on living room lights. Alexa, ask Plex play Kill Bill 2. Alexa, ask Plex stop. Alexa, ask Roomba start cleaning. Alexa, ask Roomba stop cleaning. Alexa, trigger bedtime.
That turns off the heating, the TV.
Alexa,
lights.
trigger wake up room.
It's only just a short demo, and that was done like 18 months ago now, so just gives you an idea of linking in with home devices. You can write your own skills to link in with your own devices that you might have made. So the things that we've got, say, in the labs, you could get that for the voice control as well. You could even sort of do things like voice control a sprinkler system. Using box, the hints sort of thing. But you could write an interface that works with just say, Alexa, water the lawn, turns on, or water the lawn on a hot day, whatever you sort of want. We're going to look at how you might write that sort of side of the software, how you might sort of integrate that together. the lab's all about that. There's a couple of other videos available on this. This is my own sort of little channel with demos on. There's another one from a project student I worked with last year. I think I demoed it with Node-RED last time. He wrote a voice interface using fidgets for it, and sort of picked up temperatures or when a slider was moving or opened the door, that sort of thing, according to stuff that we've done just with that sort of fidget kit. He did it with a combination of Node-RED and the Amazon Echo skills to build with it. So quite nice to sort of be able to build your own environment for that. And that's really what we're sort of looking at in the labs, and I say, and today. Got everything ready. Think about it, I thought I had that thing ready. Mistake there. I want to just slide through the PDFs. Right. This is going to get embarrassing. I might have left it up in the office. Just as an emergency thing, I'm going to have to go through the slides for this. Also, another quick look at the Alexa panel. Let's get started with. This. Sorry about that. But it's already prepared. So we're going to have a look at building your own skills with Amazon Echo. These slides essentially come from Amazon themselves. So it's obviously promoting their particular session. But what we do here is going to be very similar to if you were doing it with the Google sort of one to be able to create. It depends on what API they're providing you with. They're offering a wider and wider range on both sides. Amazon have been at it for a lot longer than the other people, the other manufacturers. So they've obviously got more devices out. Their software is probably a bit better developed, but they're snapping at the heels are people like Google and other ones, and other companies embedding the software and hardware from Alexa and Google into their own devices. So these smart TVs that pick up talking with them. LG are currently doing a promotion on their TVs to be able to sort of have that interaction, a sort of Amazon Echo sort of type interaction. They're ranging from these, the big sort of tall speakers which you've got, they're fairly weighty when you pick them up, you've got a good quality speaker in them, down to the small Echo dots there at the front. They're all powered devices, so they need a plug to put them in. But they've got their own screen-based devices. The one that's next to the tall one is a wireless version of it. It can be sort of listening to it. But being wireless, and because the act of this listening saps up power, as we've seen with sort of node systems, that one's operated just by a button on it. It only listens when you click the button, basically. But it does mean that you can take it out and about with you. So it just sort of it's got its own sort of battery charging inside. You can sort of take it outside and work with it like that without any power cord to it. So there's a wide sort of variety of these sorts of things, and whilst they're sort of nice to see and they're very much at the front end for commercial sort of attractiveness to everyday users, as software developers, we're more interested in, well, okay, yeah, that's the device. What can we do with it? Can we sort of write our own software and link it into what we want? Now, I'm just going to give you an idea of how this is linked to Amazon developer pages. They all work, both the Amazon and Echo and Echo Dot, work through connecting back to Amazon's cloud service. And contrary to sort of a lot of thoughts, nothing is actually processed on the device itself. So that speaker is purely a voice collection point to it. It doesn't actually do any recognition of what the words are or which skills to invoke, anything like that. It just collects the data and passes it off to Amazon services. So that's why it needs a constant net connection. So that Alexa web service, if you like, the framework, lives out in the cloud for it, and that's the part on the cloud that does the speech recognition. So what actually is going to be happening with these, and it's the same thing that's happening with Google ones, that when you do this, it's geared up to sort of recognise its keyword, and then package that up as some like, come to an MP3 if you like, and bung it up to the net, to those sort of cloud services. So it's not actually done on that device itself. So the speech recognition and the natural language processing is done out there on the sort of cloud to it. That way it saves having to, as these things improve, it saves having to download updates all the time onto your actual sort of device, because all that is more or less like a dumb terminal collecting the sort of data off. Now, what you'd be working with is, as a developer, you'd be working with this Alexa Skills Kit to take these things that are uploaded, these sort of voice recognitions, and using their speech recognition and this natural language understanding, you'll be provided with what was actually said. So they provide you with what the phrase is as a string of text, if you like. So what's the actual words of you? You don't actually have to do anything like that. You have to write the software that then interprets what they say. So interprets that sort of string that's gone in. So you can then sort of use that skills kit to create your own content and interact with your own audience, your own sort of consumers or whatever, to provide, I mean, these things are already out there, weather updates, sports updates, sort of news and things like that, but to write your own applications as well to sort of get out there. But also available, the Amazon Voice Services is a thing more aimed at commercial implementers, not your sort of standard software developers writing their own sort of skills, but more aimed at the electronics manufacturers, the car manufacturers, watch manufacturers, those sorts of things, where they build that collection of the data. So they build what's in the Amazon Echo, or the Dot or whatever, that sort of thing is built ready into your speaker, into your car, into your TV, your watch, whichever one you've sort of got. So that becomes a voice collection one, and will contact Amazon in the background doing the same sort of thing that the Echo does in its own right to it. So manufacturers of goods are coming out with saying, well, yeah, we'll just build that into our own one. So you might sort of have a little sort of intercom. I bought one of those. I'm a sucker for buying these sorts of things. Last year I bought one of the video intercoms to it. Linked into Amazon Echo, and you can sort of say call Bill or something like that, and it sort of rings on Bill's device, and when you have your Skype-like call between the two. But that was somebody just creating a little screen that they were selling, and well, you buy two, so you can have one-to-one communication, either just internal to a house or in separate locations. There's a lot of these devices coming out, as I say, particularly in cars and electronics kits. So they're all developed around using this skills kit, this Amazon skills kit to work with, and you're provided with a load of tools. And Amazon's so keen on promoting these because they know that they've got these other manufacturers very close behind them trying to get theirs. So they've created a whole raft of tutorials on how to do this and how to interact with IoT devices. And until recently, they were doing things like giving away free Echoes and free Echo Dots and things to people who actually publish skills on their pages, and provided it reached a certain number of downloads, then they will give you ranging from T-shirts to actual sort of Echoes and things like that as a way of encouraging more and more people to do it. I'm not sure that sort of thing's going on right now. But yeah, there's typical sort of things like linking into bank accounts or something like that. How much did I spend? What have I spent it on in recent years? All these manufacturers releasing their own skills to it. So Starbucks release one and just say, okay, well, you'll do some voice ordering and pick it up later on. So yeah, tell Starbucks to start my order and tell them what you want, and then I'll be there in 5 minutes or 10 minutes, and hopefully it's sort of linked through. All it is just another way of, for these commercial enterprises like Starbucks behind it, they're just offering the similar thing that you might do with a web page. You have online ordering of these things, and it's just replacing somebody typing in fixed fields. We just have to structure the interaction in such a way, and initially, and while it's still under development, some of these interactions seem a bit stilted or a bit sort of, like you're talking to a computer. Well, that's what you are doing, but it's not sort of, it's not all the way into just talking with your friends. We use loads of things like filler words. I mean, I'm full of ums, ahs, and what I'm thinking, and you've got these little interjections going on. It's not sort of geared to that. You have to still be very precise with them and give a clear phrase as to what it is. They will get better. We're still just in the start point of these. So you're building up these skills to work with, to develop them. As I say, that's what we're doing, and we're having a quick look at here. There's some resources just available if you follow through the links on the slides to work with. But just as a demo of a skill that's been built up for it, you can either have skills that are downloaded onto your device and ready available. So you just say, start the cleaning, sort of type thing, tell Alexa to, just got to be careful about waking up. Tell the device to start the Roomba, like adding that thing, or ask something to start playing a film for it. If it's not necessarily on your device already, then you can just do this bit about open a particular skill, and that'll go to Google and find the skill and start interacting with it remotely. So, for example, Alexa, open Space Facts.
Here's your fact. Jupiter's Great Red Spot is a cyclone that's presently about 1.2 times as big as Earth. As recently as 1979, it was twice Earth's diameter as illustrated here. If you like this skill, then get ready for the next great skill family bookmark that will enable you to tell Alexa what page a certain person is on in a certain book. And then ask her later, so you will never lose your spot in a book. It will be coming out in April.
Shameless promotion. Something we're going on. But he's sort of interacting with this current one, and there's these sort of parts to a sentence that it's recognising the wake word, the starting phrase about whether or not something's local or remote, and then which particular skill you're wanting. That's really like a method call, is what you're doing. You're saying, call this method, and you give them the name of a method, and then you might have some extra parameters to pass to it after. And as a developer, your initial thing is to decide what you're going to call your skill. Well, that might seem sort of trivial, in some ways, but it's got to be something that's recognisable to your user, something that they are wanting to interact with, rather than saying open my experiments or something, or open my first skill. People don't sort of say that in real life. You want something that's relative to whatever type of operation you're trying to work with. In this case, that sort of Space Facts for it. So I'll give you a quick sort of overview of what this building is. But like many things with programming, you've got to actually do it to appreciate what's sort of happening with it. And the tutorial that you'll work through will, well, one of them is a sort of random facts or quotes, or something where you can say, give me a random fact about a certain sort of topic, or that sort of, I'll give you a quote from such a body to it. But what we're going to be looking at in that lab section is getting to grips with what the actual terms are that they use. They refer to things like this voice user interface. You know, you're used to GUI user interfaces. Well, GUIs, graphical user interfaces. We've got this voice user interface and the design of that, tying over with what the utterances are, what's actually being said, and the intent, which is what you want to do out of that, to extract out what you're trying to do. In some cases, there'll be what they call one-shot interactions. Alexa, tell me the time.
It's 10:27 a.m.
That's a one-shot one. It's just that you do a question or you're a statement, you get the answer to it. Some of them might have multi-turn interactions, where you're saying, play me some music. Alexa, play me some music.
What do you want to hear?
You get a multiple. Right, Kudo. Again.
Your Amazon Music Marketplace is not configured correctly for this device.
Yeah, I haven't set it up with that one to tie in with my music. But that's a sort of multi-way thing where it needs to gather a bit more information to it. And then what comes back is what they refer to as these speech cons and SSML, a markup language that describes the responses. So the voice itself is generated on the device, but it receives a text string of that in a particular format, and they've got their own markup language for it. It's SSML. They invent these terms like speech cons that represent what that message is. But all the actual processing is done out there at Amazon's site. This is purely for collection of the data and representing the results to you. There's something called the Amazon Web Services Lambda. At some point, you've collected all this data. It's like you may sort of collect something off a web form, fill in different boxes, and you click submit, and it gets sent off. There's got to be something at the other end that's processing that, that's going to take all those parameters and do your task. It's going to look up, I need to say, what's the diameter of Uranus then? But what's something like, how far away is Jupiter? Something like that for it. So it's, you'll pass up the actual method call and the parameters associated with it, but you've got to have some sort of web service that's actually doing it, that's working on that. Now, Amazon will provide you with hosting facilities to be able to create these web services to do it in a variety of languages, or you can host it on your own server somewhere. So you could develop something over on the Google App Engine, say, or on a server somewhere. As long as it's publicly accessible, you can pass these parameters over to it, let your bit of software do its job, and send the result back to Amazon, who then relay it back to the speaker. They have a certain interface that you've got to get. These web services, they're not sort of just purely random calls or left to the devices of the individual programmer. They provide you with an interface of what to expect. That if you're writing your own implementation of one of these, here's what the interface will be, here's what Amazon's expecting it to do, and how it's passing over those. And they've got a whole skill certification program going on as well. So if you want to gain certification to offer to potential employers, then they have that sort of a part to it. So the two parts that I sort of mentioned there, the front end and the back end to it, the front end being that collection of data, somebody sort of speaking in, and then the back end being this programming logic, somewhere, a bit of code, and that programming logic It can be in whatever language you like, so long as your server supports that language, and you've got this, as long as the interface you're using it is in this specific interface that Amazon suggests to you. So if you want to write it in Java, Python, Node or something like that, you can sort of use a huge sort of variety of them, whichever suits you best. It may well be that Amazon don't support your language, but you can do it on, if you can get that language supported on another server somewhere, then you can sort of interact with that. So if this was, say, writing a voice interface to your own application, such as sprinkler control, you'd need to decide, you need to write a skill where you decide what the key phrases are to wake it up, and to what the operations actually are that you want to do. So you might want to say, Alexa, turn on the sprinkler. Hopefully it's heard me now.
Sorry, I didn't find a device named Sprinkler.
So he's trying to do something, he's recognising what I'm sort of saying as I'm sort of going through. But you could have that sort of skill linked in then, so that your request is passed over to your back-end programming that does perhaps sort of send the message back to your sprinkler system to turn on or to turn off, or to program it for a certain sort of time of day to sort of work with. Now, it's not something that's being asked for the assignment here. I asked you to think about how you might put in a voice interface to it. What sorts of things would be involved? Where would the software live for each one of these? And if you were to sort of put that extra bit in, I would expect there's two parts to it. Basically, one on that sort of front end part of it, which would reside on your local voice collection device, and then that back end part over on some cloud-based server for it. So the two together are what sort of give you that, and you can create the voice interface part, the collection, the delivery of the result. This developer, Amazon.com, gets up an account there, and then it's a choice for you where you want to host that actual implementation. And AWS is one place to do it. And to be fair, most people actually do choose that, and it's all in one for it. So the stages that we're sort of going through, these sort of 6 stages outlined there. The first one, this creating this voice user interface. In some ways, that's the more fun part. Where you're deciding what to recognise, what your users are going to pick up on. And you'll just specify in a certain format what these utterances are going to be. More than that, just in a sort of second to it. We then move on, once you've decided what your voice interface is going to be, and you can work a bit more on it after, you've then got this Lambda function working in the sort of background. And the rest of it, though, all this bit about tying the lot together, about how you tie in those utterances with those actual implementations, that's done on the Amazon site, where you'll configure and test out your application, so you can do some test utterances. And as I say, you don't actually need to have an actual device to this. They've got emulators, so you can test it online for it. Just as an example to show you that in action. Open one of the tabs. This links underneath somewhere. You can get the echosim.io. I'll turn that one off so it's not listening to me. And so long as I think you have to have an Amazon account to be able to use this. And it just uses a website as a way of interacting with it. And it just asks for access to your microphone, and you turn the microphone on just by holding the space bar. I think there's another way to do it. You can either hold the microphone button or hold down the space bar. Alexa, what time is it? Slow response. It's like the
The time is 10:36 a.m.
so you can try your skills out just on your own laptop or your own sort of device. As I say, they're trying to give you as many of these tools to help you with it. They're trying to sort of really promote their own things to get more and more people doing it. So they're trying to make it as easy as possible to do it and get really flexible and offer as many languages as they can. And I think they've still got the edge on Google to it in terms of what they've got. But they're catching up to sort of work on it. So give that a try, or just even if you want to sort of demonstrate what it is. Project structure. When we're creating it, and as I say, you'll learn more about this in trying one of the labs out. You will have a collection of speech assets representing these utterances and what's called the intents. The utterance is what you're speaking to it, the intent, what you do when you do a certain utterance. And then there'll be some source code associated with that. Now, the source code for this sort of basic project structure is all done in JavaScript to sort of work with. They do a lot of work with JSON and the like. So the actual sort of voice interface part to it, yes, you are tied to a particular language. That may change. It may already have changed, but my last reckoning, you just have that sort of approach to it. And you create a project with these particular folders available, and when you work through the tutorial, you'll have an online development environment, so you don't need to download Eclipse or an IDE or anything. It's all done interactively through sort of pages and these sort of folders of new utterances as you're building them up to sort of work with it. So yeah, you've got these utterances and this way about how it's all linked together to do with the voice interface and the index.j JavaScript. I would just sort of have a look at one of these. Or this is just where I brought in the bit about the echo sim, if you want to try it out. The sort of things that you're working on, you've got this sort of trigger phrase where you give the wake up word, and then you've got a starting phrase, which can be a variety of openers. You don't need to say open space facts. You can start, launch, ask, tell. They've got these synonyms for the different sort of things, and then your skill invocation name to sort of work with for it. You might also supply a parameter to that. So you've they're all really, when you sort of look behind these, look at it from a programmer point of view, that Alexa Ask Space Facts for Trivia is a method call with some parameters in there. It's just not as formal way as we're used to doing. Like, you know, with your Java or something like that, you have an object dot upload tag data, and then in brackets tag data dot, tag data TD or something as you're sending it up. But there you've got the thing to say, start the program, here's a method, here's the parameter to sort of work with. So, Alexa, ask space facts for trivia.
Here's your fact. The biggest known star currently is UY's Cutie, a bright red supergiant, located 9,500 light years away in the Scutum constellation. It is more than 1,708 times the size of the Sun. If you like this skill, then get ready for the next great skill family bookmark that will enable you to tell Alexa what page a certain person is on in a certain book, and then ask her later so you will never lose your spot in a book. It will be coming out in April.
And if you don't supply it enough, Alexa, ask space facts. And just wondering who's waiting then for something to come on. Now, I was sort of half expecting you to say, ask space facts for what? Sort of puncture, but there it's just, it's not got enough information to follow. You're getting a sort of a parameters unknown type approach with there. So there you've got that sort of utterance associated with it. You've got the intent that you want to do, the utterance being the phrases, and there I had trivia, a fact, give me information, tell me something. They're all just the same sort of phrase for trivia. So you supply to the voice interface all these synonym phrases for what people might say, because people don't talk in a uniform way. They do use different words to ask for things. They ask for things in a different sort of order, perhaps, to what's normally sort of expected. So in terms of how it works, as I sort of mentioned, that you've got this the audio side, your echo, picking up that audio data, processing it, collecting that voicing when you do give the start phrase to it, and then uploading it to the Amazon Alexa cloud. Then that will go off and sort out what you actually said. Okay, the Amazon cloud takes that phrase, works out what the actual words are that you said, does it fit in with a certain structure from some skill already, and will then invoke your remote far side there, your remote actual implementation of it. You'll get a response, and what gets sent back to Alexa is what they call cards of information to tell the user with. Now this is speech recognition, very tricky. I mean, I don't know if any of you saw the things like artificial intelligence modules, we might sort of look at this and the like, or have done any sort of investigation in it. But yeah, definitely sort of pretty tricky to do. Not only has it got to cope with my ridiculous Bolton accent, but it's also got to cope with Southern accents, even more ridiculous. French accents, different accents it's got to cope with basically. It's got to cope with different sort of tones, deep voices, high voices, male voices, female voices, that sort of thing, and how things can appear to sound the same. They can be homonyms, they sort of sound the same, but like that's a sort of the word to describe that's the particular phrase and how it should be pronounced. Now when you see that, what might be going through your mind of what it's saying? I mean, hopefully it's 40 times or whatever is what it's trying to sort of represent in terms of speech. But are you meaning 40 times, 40 times, or are you meaning it's 40 times? You're getting some biscuits 40 times and things like that. Now it might depend on context, what they're going on, but those two phrases sound the same to it. And it's not just those two phrases. When you start including golf, or something like that, you're a keen golfer, you might have 40 times. So you've got 40 times there, interpreted perhaps in 3 different ways. Depending sometimes on the context of what you're sort of doing. It's hard to recognise what they're doing. And like, it's often when you yourself overhear something, and they sort of said a certain phrase, and you sort of say, oh yeah, you did say that after all, or something, and it's the context that it's sort of in. So that recognition there is down to having to sort of pick these things up and decide which one of those phrases we've worked with. And that's where this natural language understanding comes in for it. That's Amazon's job to do, but you've got to supply a series of utterances. And you'll find yourself sort of coding up these utterances, rather like this sort of thing, to say they are like the parameters that you're passing. We've got this space facts running. You're trying to pass in a parameter. So you're saying, I want something called a fact, a space fact, tell me a space fact. They are all the things that are really the same thing. You're asking them for the same stuff. You're just offering your users different ways of asking for the same thing. So in the context of, in this case, space facts, that's the sort of thing that it's going to be listening out for. And you're sort of providing some sort of training data for it then, to map that user input to a particular behaviour. And the more of these things that you can provide, the better your interaction with your users is going to be. If you only allow them to say, that second one, give me a space fact, then yeah, people are going to have to remember specific things. Whereas if you can have it in a variety of ones, turn on living room light on, make it brighter in the living room. Again, all meaning the same thing. You've got to decide what those utterances are going to be. So in one of these sort of tutorials as you work through it, you'll be asked to sort of provide some utterances. It'll tell you which ones to do. And then we have, what do you do when you actually do that utterance? What's the intent? What's the meaning of what you want to do to it? So if you do say, turn on lights, what's the actual method that you want to invoke over on that server? You want to presumably set a particular value over for your light system to be set to be turned on, and then pass a message to your actual device to turn it on, and then perhaps sort of send a response back to your device saying yes, your speech device saying yes, I've done that. So the sorts of thing, if you think about what you're doing in the lab, about how you say open the lock, if you want to have a voice interface to that, you might want to say, okay, open lock to C205. You've got to extract out the key phrases there, open, lock, maybe, or just open. You might say open lock C205, or you might say open C205. You've got a key phrase open, and you've got this C205 that needs to get passed off. And your server side, what that's got to do is identify that you're wanting to open something, that you've got this C205, so it's got to decide, well, how do I actually open that lock? And that's up to your, what we've got in the labs has been that subscriber. You were doing it through MQTT. And you had something that said when you receive this message, then set the servo mode to do that. So that's what is happening over on the server, but you want to sort of pass something in return to say, yes, I've done that. And in your current application that you're developing, you confirm that the door is open by writing into a database. To sort of say that. You could confirm what you've done by sending back to the device, your Echo device, saying, yes, okay, the door's open now, to sort of work on. But all these sort of intents, what you're doing, there's ones that are belonging to you, to your application, but also Amazon insists that you have an array of intents yourself that are generic across all interaction with Amazon Echo. So they do insist that you have things like a stop intent and a cancel intent or a help intent, so that if you're interacting with your device and the user says stop, how does your actual application do that? So you must have the implementation of those. That's rather like in Java, where you have an interface. You have a class interface, and they specify what methods you should have to it. You must have these methods available, but then it's left to you how to stop or how to cancel or how to help for it. So those behaviours that it's talking about, they're all linked really to programming terms in the background, but those behaviours they're meant to be just specified in sort of JSON. And eventually, you get this sort of response going back. That's our sort of initial thing. You initially have that wake keyword to sort of wake it up. You then get it sent across. You've got these selection of JSON intents to work with that will, out of that, establish some sort of request to your implementation of it. And coming back then, your response comes back from that service in JSON. That gets sent, and the format of that JSON is dictated by Amazon. You must sort of generate this JSON string of a particular format so that Amazon can then recontact your device and actually send that response back out to them. So long as you follow their framework for doing it, you've got quite a free hand for sort of working on it. And it's these intents that are the connection to that sort of outside. You've got over the right-hand side there, you've got the actual parameter that you're passing, but the yellow, the line ones, that's the intent that you want. Get a fact intent, get a light intent, get a heating intent. So you're specifying basically the method there that you want, and then the parameter that you're passing over. They've moved away from this idea of just straightforward giving you an API and saying, well, this is the library, you learn how to use this sort of thing. they're giving you much more this sort of higher level and giving you a framework to work in, to sort of develop on. They say, well, yeah, this is our framework, you sort of work with it. So these intents, they're the connection to sort of work on. You've got where that data was coming from. You've got like a request ID to identify it, which language perhaps it's in, when it was sent, and then which intent it's associated with. So get this sort of fact intent. And this thing called slots can be what parameters you're working to sort of pass over. And then somewhere at the other side, you'll be having some sort of implementation of this. It might be JSON here, for example. You'll create this here in sort of JavaScript rather. We've got a collection there of handlers associated with it, like when we say, if somebody says get fact to it, or what the help intent is, that get fact is okay, well let's go off and we've got a random array of facts, let's choose a random number, find a fact out of this, put it into our response and send it back. That's a real sort of simple implementation of, say, a get fact. They're already available somewhere, it's just a question of choosing them out of some sort of random array, and then putting that back into this thing at the bottom of there on line 120, is it, yeah? That var speech output to create the response, and then the init tells you to actually say it or send it back to your speaker to sort of do it. So yes, you have to do certain intents yourself to it. Some are optional, some are mandatory to put into it. Certainly, if you're doing certification for these skills that you're developing, if you want to release them to the public, they have to have certain key intents put in there. You have to follow a certain standard. You can just write your own application and just run it on your own device if you like. It just means that, you know, without a lot of these sort of things, and not necessarily follow strictly their model, but it just means that you'll only be able to run it on your local device. You couldn't publish it on the Amazon store, if you like, for people to be able to get these skills to work with. Just finally, we're sort of running out of time. As I say, the end point is the point at which where that code is actually running to it, the bit that generates your space fact, fits the turns a phrase into an actual light turning on to it. Wherever you put it, it's obviously got to be internet accessible, because it's just going to be there as a web service. It must adhere to that service interface. The Amazon will be expecting a particular interface, and the message needs to be passed as JSON for it, and either implement it as your own web service anywhere you like, or on this AWS Lambda to do it over a particular port. So they're not sort of necessarily saying you must use our services to implement it. Put it where you like, but yeah, people often do use their sort of own one. And it's then up to your endpoint to sort of create